In life spanning, there is no plan B. I'm Jean Fallacara, and my guests are coming to this podcast for a reason. There's no rules, no BS, just pure biohacking. I don't want to know what you have to sell. I want to know who you are. Welcome to the No Plan B podcast. Today I'm very thrilled because we're going to talk about science with my guest, Anna Wendt. And she's into genetics, epigenetics, and biology in general, longevity. She's going to talk a lot about what she does in this field, but where she's coming from, it's even more important for us and for me. Anna, I'm not going to do an extended presentation of all your skill, where you're studied and everything, but I'll be honored if you could do it for me. And it's going to be way more accurate than if I do it.
Yeah, absolutely. Thank you for that introduction, Gene, and super excited to have this conversation with you today. So I appreciate you giving me this opportunity to do so. But a really, 30,000-foot introduction to myself. I'm from a small town north of Dayton, Ohio originally, and ended up here in Lexington, Kentucky for school. So I went to the University of Kentucky. Not many people know this, I think, but I actually went to study animal science, more of that large animal aspect. Yeah, to become a veterinarian at first. Never thought I'd change my major. Went down more of the traditional biology class route. Did a couple cell signaling laboratories that were really interesting and really piqued my interest for genetic counseling. So understanding those risk variants for family members and how that's going to affect risk of disease later on in life. So that really is where my interest in the molecular genetics began. Now, I did try to go down that genetic counselor path that I mentioned, but actually kind of took a break from applying to schools and got convinced to stay at my position I took right outside of school, which was also very, very unique. It was going to be at a compounding pharmacy in Nicholasville, Kentucky, where we specialized in unique peptide products and provided them to, big word right there, the peptides.
Today, yes.
Really trending. So we can talk about that too. But that's when I had that aha moment where I realized there's this entire space out there. And by space, I mean that cash pay medicine area where there are healthcare providers who are studying longevity or functional anti-aging medicine, where they're actually trying to optimize health rather than treating someone who's sick or disease burdened. So I remember never knowing, right? We don't know what we don't know. So that really piqued my interest as well. And I went on to actually help create the International Peptide Society, where we educated our healthcare providers on what these peptides are, how to use them, get them involved in some clinical trials as well. So that was my entryway into this space and how I became interested. But what I do now is I actually really talk with healthcare providers still, about 35, 50 new healthcare providers every week, and teach them how to use biological age-based testing through DNA through epigenetics or DNA methylation to quantify things like those peptide products or other protocol treatment plans to, again, help reduce that number one risk factor being aging.
Wow. Okay. Before we got our feet into this technology and techniques and the methylation and everything in detail, a question for you. So you've been a scientist almost your whole life. Do you think it's based on genetics?
Oh, it may be, I do remember just being interested in, why things are the way they are. What is their underlying biology? Why do they work a certain way? So I will say my mom and dad were not interested in biology or science. Cool. So I'll say, no, that part probably wasn't genetic. But one of my younger sisters, Claire, is actually a nurse. So we both have some science interest there.
Yeah, definitely. It's because today in our society, we see many families like if the father, the mother are doctors, you see the kids going to medical school and stuff like that. I don't know if it's like because of the ego flattering from the fathers or the mother or by conviction, but I'm always curious. I'm into science. My father was a scientist. My brother was a scientist short time and jumped away from it, and the rest of the family, no one is in science. And today I do regret almost having put all my career into science. There are so many things interesting around it. But as a kid, you were so interested into animals first, I guess, because going to vet school is like by passion. Most of the time we see like people, they don't go to vet school because they want to be rich. They go to vet school because they like animals.
Definitely. It's more of that passion, right? And can be a really hard route to take. So I started getting into more clinical work and trying out small animal vets, large animal vets, and realized it's not, maybe I wasn't so passionate about it, I guess, right? The really long hours, and kind of switch gears from there. So yeah, a lot of my friends are obviously interested in science and surrounding people who are in this longevity space as well. So when we look at, nature versus nurture, is it the genetics or is it more of the environment? I think maybe it was more of the environment for me that led me to be on this more of the scientific pathway.
Well, definitely then it's epigenetic and not genetic.
Yeah. Exactly.
Right into the topic. Can you explain what is epigenetic? Because for me, it's a word that I know, but many people around there, they just think it's something's related to diet, which is not.
Yeah. I would say that's how it's most commonly viewed if we're seeing it on social media or in articles. So let's just back up. Let's start with genetics. I want everyone to even define this first, right? Genetics, you get 50% from mom, 50% from dad. Those are your nucleotides, your A's, T's, C's, G's, kind of the backbone of your DNA, and that's never going to change unless you're doing some crazy gene editing, I want to mention. So those are not going to change. Whereas we've always had epigenetics, but it's just now becoming a lot more popularized. And epi is actually a Greek prefix. It means above or on top of. So we're just looking on top of the DNA. And there are a lot of epigenetic modifications, so changes to the DNA that's happening. And we can get into more of the weeds later on what those actually are. But a really good example I like to use is think of a computer. The hardware is going to be the genetics. That's not changing. Software equals epigenetics. So we're actually looking, hey, how are we controlling those genetics?
Yeah, that's super cool. That's an easy example to understand. So let me maybe clarify that for our listener. Epigenetics is mainly all the effects that are triggered by the environment, whatever it is, air, water, food, everything. Okay.
Absolutely. And you can go back to that, nature versus nurture kind of example as well, right? Your nature, it's going to be your DNA. That's going to be inherited again from your parents, grandparents, and generations even before that. Where that nurture part is, all right, how are our interactions from, again, the environment, the air we breathe, the way we talk to ourselves, the food, insulin sensitivity, all sorts of different things. How is that affecting the expression of our genes or your epigenetics? And how is that putting you through certain outcomes relative to disease risk?
Cool. There is hope.
Yes, there is hope, right?
Yeah.
That's a good point too, Gene, because you do see, again, a lot of these really trendy sayings like food is medicine, you're not your DNA, or you are in control. And you're like, they grab your attention. You're like, wait a second, what did that say? And then you read maybe the caption or you're scrolling a little bit longer and it would define epigenetics in there because we now have power or, again, somewhat control. We're in the driver's seat on ways to turn certain genes on and ways to turn certain genes off.
Yeah, definitely. This is the interesting part because so far we always thought generally that we're born with a certain luggage of genetics and there is nothing you can do to change it. But there's light, there is hope. And today, even if you have some genes that are like some sort of predisposition to certain illness, you can actually modify that predisposition. It's still going to be there in a way or the other. Am I right? Yeah.
You're totally correct. I think another good way to look at it too is, again, genetics. Those are stagnant. So your definitive risk if you go and get a genetic panel done and you get that testing done. Those risks aren't going to change based on genetics. What is going to change, though, is your epigenetics. So your epigenetics, I think this is more empowering. It's more hopeful, right? Because that's kind of what is happening at this very moment. And once you measure your epigenetics, you'll have a risk at that particular moment, but you can actually work to decrease that risk. Hopefully, you don't increase it by doing things that may negatively affect that risk or outcome. Yeah. So I'll be the first to tell you I'm an advocate for both. I'm obviously obsessed with epigenetics, but if you test your genetics and epigenetics, it's all going to play together. You're kind of going to get more of that, multi-omic approach using two of those omic factors to help you regulate your DNA better as the end goal.
Love it. And you just opened the door to testing genetics. This is what you do, no?
Yeah. So we test your epigenetics. So we're looking at those modifications on top of your DNA. We measure about 1.2 million different epigenetic methylation markers. So it's a lot. That's the most that we can commercially at this moment really measure in a cost-effective way. So when we look at all of that raw data, there's going to be a lot of ways you can read it. I don't know anyone in particular, not even Dr. Steve Horvath himself, who's a pioneer in this field, who can read that file with a naked eye, right? So it's really hard to understand that. And measurement actually means nothing without the interpretation of the data. So measuring your epigenetics is great. Now we need a way to interpret it. And how do we do that? And we're actually going to do that through published, validated algorithms. Whether it's created through a bioinformatics team at, a certain company or universities' academic-based partnerships as well.
But today with artificial intelligence, machine learning and everything is going to be faster and more efficient for you guys to get like straight to the point and having even more data as to, that's the beauty of this world ever changing.
Yeah, I've gotten that question, I think, more recently, right? Because we're seeing this boom in AI. And I truly believe AI from that side of data processing is only going to help us, right? We can only have so many bioinformaticists, biostatisticians, so much computer powering and memory and storage. So if we're able to do this faster, because again, it's a lot of data, we have to parse through 1.2 million epigenetic methylation markers for every person who takes the test.
Not only that's a lot, but you have the human factor that is in the processing itself that creates some things that is not questionable, but that could create some errors with machine learning and definitely artificial intelligence. 15 billion will be nothing to analyze and faster and even more accurately. Now, you mentioned a word that is most of the time in your vocabulary for daily operations, methylation. What is it?
Yeah, so DNA methylation is an epigenetic modification. So again, a change to the DNA sequence or pattern. And if we go back to, high school, college, when we took biochemistry, a methylation marker is going to be a CH3. So it's going to be a carbon, it's going to be 3 hydrogens attached to it, all right? That's the most basic definition, but these molecules play such an important role in our biology. It's pretty crazy, Gene. If you have a position that is methylated, so the methylation molecule is attached to that particular section of the gene, that gene is turned off or less expressed. Where the opposite is true as well. If that methylation is not present, that carbon and the 3 hydrogens, then that position is more expressed or more turned on. So think of it as a light switch, right? We're giving you all these different examples. It's either turned on or turned off, but it's not binary. It's more of a dimmer, so to speak. So it's more of a percentage of methylation, of DNA methylation at all of our different genes and positions that we're able to measure.
So there is a grade of methylation that can happen to those gene expression. Can that lead to overexpression of certain genes and turn into illness?
It can. Now, I want to be very clear too. A lot of people think methylation is bad because they hear, methylation, MTHFR gene, right? In our case, DNA methylation, we're not talking about a gene. We're just talking about turning genes on and off. And some genes we want turned on. You want your tumor suppressor genes turned on, but you want some genes turned off, like your oncogenes or your cancer genes, right? So it's all about having a healthy balance of these CH3 groups, the DNA methylation in the body. So we want to do things that actively, what I like to call, shift your epigenetic methylation markers in your favor, all right? So I think that's, good to understand from a fundamental point of view. Now, getting back to your question, Gene, yes. If we have certain genes turned on or turned off that we don't want it to be, it can lead to disease. So one that is a really good example off the top of my head is an ABCG1 gene. So this, in a very easy way to explain this, it is heavily involved in insulin sensitivity. So if you have this gene shut off, if you have more methylation at this gene and it's turned off, that actually increases your risk for type 2 diabetes. Now, furthermore, this is where you get into more of the pharmacoepigenetics. So it's like,
getting
PGX, for pharmacogenetic testing, but pharmacoepigenetic testing, it'll be available in the next decade or so. If you take a statin, and this is very heavily validated in the research, if you take a statin, it increases your epigenetic methylation at ABCG1 gene, which turns the genes off, which actually affects your insulin sensitivity, which increases your chance for type 2 diabetes. So that is why people who take statins actually have an increased risk for type 2 diabetes. So it's a cool little connection, right? And we're starting to make more and more of those.
Yeah. And when you get to the point that is triggered and you are you are sensitive and you have diabetes, Can you reverse that?
Yeah, you actually can. So again, this is all measurable, and these epigenetic methylation markers can be modified by different lifestyle factors, again, supplements, medications, procedural-based therapies. So in this case, if the test I'm talking about right now, measuring the ABCG1 gene, and there's another gene we look at, that's actually been proven in the literature to be more accurate than HbA1c levels and fasting insulin. And I can tell you, if you're going to see the symptoms of type 2 diabetes 7 years before you actually get that onset of disease. Yeah, so it's all about preventative. But yes, you are able to actively uptake therapies to reduce methylation or add methylation depending on the position.
So 2 questions are coming from there.
Yeah.
You're into the longevity. Longevity is actually trying to figure out the best way to avoid illness, to get in the better shape, to not getting too old too fast. So that falls into my second question, will become my first. Your testing are related to age, correct?
Yes, that is correct.
Okay.
Yeah, we truly believe, I would say, aging is more of that disease type.
Yeah, it is a disease. Aging is a disease. Yeah, there's a polemic on that. Like some people say it's a natural process. The other is just like it's a disease. I do agree that it's a disease. But what's your take on that?
I think it's interesting. And I've spoken with several of my colleagues on this. Dr. Kara Fitzgerald, we chatted about this before too. Disease, people don't like it because disease has a negative connotation, right?
It's like an hospital stuff, yeah.
Exactly. And as we age, we become more wise. We, age gracefully. We are able to experience life. Maybe we have children. Maybe we get a pet. Maybe we start a new business, right? Whatever it is, whatever your why is in terms of aging. So I understand why people don't like it. But I think it's necessary to define aging as a disease for it to get the attention that it needs, in order to get funding for research, in order to start being able to get drugs, FDA approved for aging, to be able to try and measure and reverse this process a little bit better. So if you want to get technical, I think it's been studied time and time again and very much proven in the literature that aging is at least that number one risk factor for almost every single chronic disease and death. So it's a fine line if you want to count that as equivalent to aging being a disease.
Yeah, it's going to be a long road to get that approved by the CDC and the FDA. But I don't know if we will see it, but hopefully, yes. So why people would go to make those testing, and just like, of course, for longevity and to maybe forecast if they have any sensitivity or prevention to have certain genetic expressed disease. But I would do it just for the fun of knowing my biological age.
Yeah. I'm just like you, Gene. I think too, I want to know everything about myself, right? More knowledge is power, kind of. I think it goes back into your case and probably a lot of what your listeners are interested in, and looking at some of your previous shows as well. If you want to talk about biohacking, we need something to measure, right? That's what biohacking is. You're looking at a baseline. You're trying to get it better. You're trying to optimize your health. And as it relates to health, no better measurement than aging, because it is that number one risk factor for most chronic disease and death. So, every other disease is going to be secondary as it relates to aging. We get those diseases because we are aging. So if we're able to measure this process, even before we're accelerated, then we'll be able to reverse this and mitigate those risks for all of those different disease types. So I think, again, more knowledge is power. The more we know how we're aging, the more that's going to help us make decisions as it relates to our health.
You're capable of giving the biological age of a person, but to do that, you need to have certain feedback and standard and referential that you can put the case of your patient against a certain database that is comparable. How do you do that? How many samples have you collected? What's the volume of data that you have?
Yeah, so this becomes a tricky question, and I'll tell you why. I'll clarify. I want to know what you're exactly asking so I can answer the question properly. So people ask, how are the algorithms created, right? And that's going to be different for every single outcome. Yeah. So that's one question. Mm-hmm. And then the other question is, well, how many tests have you run, and who do we compare you against? Which I think is what you're asking.
That's the second, and actually the global question, to make it simple, is how accurate is the result? Mm-hmm.
Mm-hmm. Yeah, so I'll start with the latter first. That's kind of the first question. So we've actually tested about 30,000 patients to date over the past 3 years we've been open. Now, again, those people are very, very healthy. They're choosing to take our test. They're a selected population. So we make that very, very clear to people who are taking our test. So if you're if you're below the average trend line for any of those we spit out,
going to be a deception.
You're doing really good. I really do, Gene. I call our population the best of the best. It's super unique. They're people who are, again, putting a lot of money, a lot of dollars to these healthcare providers. And I know we're getting those healthy patients because we mostly work with healthcare providers, right? And that's their patient avatar, so to speak. So that's who we're comparing you to against. That's how many people we've tested. Now, again, in terms of the algorithmic creation, Gene, you might have to pull me out here because I'll get too much into the science.
No, please.
But something that's brand new, really haven't spoken with anyone about on this, is a new omic M age we just recently created with Harvard. This is the first ever biological age clock that has used metabolic, proteomic, and then clinical lab measurement values to create a biological age-based test. Ooh. So yes, it's very, very interesting. And right now, it's been measured up against all of the other algorithms that have been created and is looking to be the most predictable. Besides COPD, GrimAge beats us on COPD because it
explain what it is. Yes, so please.
Smoking.
Yeah.
So this omic M-age predictor is actually able to tell you your risk of 7 different diseases. So we can tell you your risk of death, type 2 diabetes, COPD, cancer, depression, and there are 2 more that I can't think of off at the top of my head, but they're in that same realm. So that's really interesting because no clock has ever been able to do that before or has reported out on that. And not only that, Gene, but this omic M-age clock that we've created is actually created using 36 MRSs. So this is very important. And this is where epigenetics is going in the future. An MRS stands for a methylation risk score. Some of your listeners or you may relate to like a polygenic risk score for genetics. A methylation risk score is going to take more than one, so I guess 2 or more methylation positions, and it's going to create an algorithm to be predictive of that outcome. So we use 36 MRSs from a clinical lab side, a proteomic side, and a metabolomic side to create this omic M age. So we're able to actually measure using epigenetics things like your HbA1c, hematocrit, your creatinine, and a lot of other values. So now, not only do we know your biological age, not only do we know your risk of those 7 diseases, we now know which factor, which clinical lab value, which proteomic value, which metabolomic value through those methylation risk scores is making your omic age increased or decreased.
Ooh.
So now we can go back and say why, right? And I think that's been the missing link.
Absolutely.
Is people get a biological age back and they go, well, why does this happen? And we go,
what can I do? I
don't know.
You have to live with it.
Exactly. So we only used to know correlation, right?
Yeah.
High BMI, smoking, drinking, things that are really intuitive. But now we can actually look at these scores and say, oh, Gene, actually, your creatinine looks to be really, really high. We need it to be a little bit lower so you can get a lower biological age score. And that's the future of this testing.
Yeah, that's fascinating. I was reading a publication yesterday about some sugar molecule that on cells that were related to age and things like that. There's a company out there doing that as well. I love that. I love the fact that we're getting more and more accurate, but I do love deeply what you just said, that knowing the why and knowing what to do, it's the missing link. Like we have so much data that we're gathering every day, and biohacker or not biohackers, but most people into the fitness and wellness industry, what they do, they're triggering anxiety because of their protocols and because of all the pills that they have to ingest on a daily basis to make sure that everything goes as they think it has to go. I don't wear any tracker. I'm far away from that now. I gave up on all these things. I just go with the feeling of how I am. On what you said before, there is one detail I noticed, and I want you to explain me this one because it's a bridge in between psychiatry and biology. You said a marker about depression.
Yeah.
Tell me about that. Tell me more about that.
So we're able to actually report out your risk of depression. And those 7 diseases that I mentioned, those were chosen because we had that data in our Harvard cohort. So let me tell you about the population that we had and how we created that and how we're able to actually report out on that. We took about 5,000 of Harvard's biobank samples. And these are people that they have biomarkers on from when they were a child. Heck, maybe even when they were born, right? Okay. All the way up until some of them even, die, pass away. But again, for a good 40 to 60 year span of their entire life. So we can go back and look at these medical records and say, oh, this person got depression. Which epigenetic DNA methylation markers are changing that would give that person depression, right? So we have the phenotypic outcomes. And that's a good point. I'm glad you asked that question and brought it up, because we have to have the outcome data. We have to have the longitudinal outcome data, or we wouldn't be able to report out on that. Now, I will tell you as well, aside from just being able to report out, hey, here's your chance of getting depression, there's a massive psychosocial analysis aspect of a lot of those mental health disorders and aging. All right. So we know things like schizophrenia, bipolar disorder, depression, suicidal thoughts. If you are experiencing any of those will also in turn cause your epigenetic age to be increased as well. So a lot of research going into that and how we can actually reverse those patterns, or what's the mechanism of action behind that.
Yeah, very interesting. I love that thing, because this is the beauty of where we're living today, and the beauty of bringing the neuroscience into this brutal science that we've been studying in when we were younger. Genetics, immunology, biochemistry, whatever. And now you have the neuroscience is putting this bridge in between psychology, psychiatry, mental health, and the effect on the body and the consequences. Now I have another tricky question for you.
Yes, I like them.
Okay. You mentioned that most of your patient and clients, or patient, whatever, are wealthy people that spend money into their health and optimizing their health. So the amount of sample and data that you have is mainly rich people. Mm-hmm. Do you think that people with money will live longer?
Oh, you're going to do me dirty here. That is a hard question. I don't know if it's necessarily people with money are going to live longer. I think people who have more resources available to them, which money could be one of them, right? It's been shown for them to live longer. So people who aren't going through a lot of not even socioeconomic base, but other types of hardships, whether it be different traumatic events, stressors, abuse, polyvictimization, even different income levels of not even your family, but neighborhood. So, if you grow up in a neighborhood that has low income levels, but you personally, your family is a higher income level household, that still affects your epigenetics and your outcomes. To answer your question more directly, though, I think money is obviously a resource. So I think it's probably easier for those who do have a higher income to access better longevity-based tools. Because again, those people who are doing that, the Brian Johnsons of the world, people who are posting everything that they do, they are, their goal is, yes, to live longer, but I think the underlying goal is for them to increase their health span. So how many healthy years can I have at the end of my life instead of being, 80, 90, or 100 and being stuck to the couch, not being able to walk to the bathroom, not being able to properly take care of yourself, right? So I think it comes more to, people with other resources are going to be able to, be more active in terms of their just overall health.
Yeah, I agree. I'm watching what Brian Johnson is doing. There's give and take. Not everything that he's doing is, my opinion, is on purpose. There is some sort of egocentric action behind that process, and investing that much money on your own person. For me, I think that you could do way better in the population with $2 million than putting just that on pills and things that he has difficulties to justify where he puts that money on the second plan. And the second is right into your field of activities. He's trying to do a blueprint, but the blueprint is definitely in accuracy with his type of genetics. Mm-hmm. There are some things that doesn't work there.
Definitively. Yeah. You need all encompassing. I think so too. So genetics, epigenetics, and we get into that multiome, the proteome, metabolome, your exposome, your microbiome, right? So again, coming back to biohacking, coming back to, hey, you can't manage what you can't measure. There needs to be a test for every single one of them. There needs to be something that's quantifying in order to see a change before and after. And I think talking about what we just discussed, Jean, the more resources, the money, I want everyone here listening and saying, I don't want them rolling their eyes saying, oh, here we go. We're going to talk about some expensive therapy or whatnot, right? I want everyone who's listening to know that this can be very, very cheap. You can do things that don't cost you a cent to help your longevity,
I love it.
right? I'm claiming this title, at least for my company, more report reviews in the world than probably anyone else for biological age, epigenetic methylation. I truly believe that. Thousands now. And the people who have the best age-related outcomes are people who have a simple life. And by simple, I mean they live on the farm. They live on a farm. They grow their own food. They have very low stress. They move their body, most hours of the day. They're standing, they're walking. It doesn't have to be vigorous exercise. They're being mindful. They're doing meditation. They're doing breath work. They have quality relationships over quantity relationships. And they're eating quality food over quantity food, and getting good sleep. That's, those things that I just named there. It's a lot.
It's a lot, but they don't cost. Yeah, they don't cost. They're free.
But they don't cost. And that's my point. I think that's, people just need to realize it. It's not going to be pretty. You're going to have to make some habitual lifestyle changes to get there. But those things are all free, no charge to you.
That's so true. That's so true. Often I have people asking me, hey, how do I start biohacking? Well, just by waking up and drinking water.
Yeah. Wake up at the same time every day.
Yeah. And drink a bit of water, put some salt, lemon, it's going to be even better. But that's the start. Get disciplined a bit in your life and don't go for easy shortcut. That's the problem for society. We're always trying to chase this magic pill that will give us the longevity and get us rich and happy and famous whatsoever. Anyway, to go back to the story of your life, I've seen two websites, at least two websites on what you have, Everything Epigenetics and True Diagnostic. What's the difference between both?
Yeah, so True Diagnostic, I'm a co-founder there, is my company. That is our testing company. So True Diagnostic, the epigenetic company, that is where we serve healthcare providers, consumers alike, and we really pride ourselves in offering the most scientifically validated aging algorithms or epigenetic insights. True Diagnostic would be a failure of a company if all we did was aging. So we're doing more, in terms of epigenetics. Where Everything Epigenetics, I actually started this, it's almost probably been a year ago, as an educational platform into epigenetics.
Okay.
So you're not going to find much about epigenetics at, conferences or blogs, et cetera. So, originally we were going to create that through True Diagnostic. And I said, you know what, I'm just going to take it over. I want to be able to offer this, kind of create a platform. So it's unaffiliated with True Diagnostic, but obviously we educate on I educate on epigenetics and what it means, what's the impact it has on our health. So it will become one day, Gene, where we can look and say, okay, this particular loci or this particular epigenetic methylation position, we want it at this number. Here's what you do to make it that way, right? It'll get there eventually. Yeah. That's what we do for genetics right now. And 10 years ago with genetics, that didn't seem possible, right?
So true. So true. Yeah. I'm with you 100% on that. And as you said at the beginning of the podcast, like knowledge is power. But knowledge comes only with education. And if you do that on that platform, it's beautiful because, people are trying to get educated. They go on social media most of the time. That's the problem because there is a lot of crap out there.
Yeah.
So I recommend people to follow your account. We're going to put all the details on your account, but it's Everything Epigenetics on Instagram. And you have value there, a lot of information. And if we are able to educate people, we're going to make them understand that, yes, it's easy to live longer. And we have to remember, let's finish with this question. I was actually, I was jumping to the conclusion, but I'm going to turn it as a question. Okay.
Yes.
What's your guess in terms of longevity? Are we human? Because if you listen to David Sinclair, there is a version that we can live up to 175 years. Some others are saying 150, some 125, some other just 100, and some pretend to say 200. And knowing genetics and the senescence in general, what's your take on that?
Yeah, I think with the science and what I know so far, I think right now there is a cap for lifespan. Probably around someone living on this earth today is probably going to live to around 130, 150-year-old range is probably what I would guess. Until there's some type of disruptive technology that becomes available, I think the lifespan will be really, really hard to beat. But again, I think a lot of these I think a lot of the people in this space, their goal is, again, making those years at the end of life very, very healthy, to have the quality of life. And again, it comes back to pushing back the onset of disease. If we can keep doing that and chipping away at that little by little by little, then we'll keep increasing lifespan little by little by little. But right now, I do think there's a cap, I'd guess around, 130, 150. But we're really going to be able to make those quality years at the end of our life. Because again, aging, the definition of aging is deterioration over time. Your cells start to look like one another. Maybe, again, an eye cell is sending a signal to a skin cell, which, those shouldn't be crossing paths, right? Yeah. So like you said, when you go into more of that senescent cellular phase, I think, again, with some drug technology and being able to live our lives and having conversations like this where we're educating on how to live longer and how to do that, I think we will see a future with both lifespan and health span increased.
Yeah, I'm on the same path as you on that. I think, between, I came with a tricky number, 142. That was the average I was coming from statistics and things like that. But we're there, from 135 to 150. Definitely, one of the most important factors that people are just like not thinking of is the fact that when you stop moving, you start dying and getting older. And that's the movement is the key of everything, because our cells, you can have all the genetics and epigenetics you want. If you're not moving, there's no expression.
Yeah. That's why I got a stand-up desk and a little walking pad, right? That article came out that said, like, sitting down for 8 to 10 hours a day is equivalent to smoking a pack of cigarettes. I was like, I'm going to order that right away. So now I can't sit down. Like I'm sitting down now talking to you because of how my podcast room is set up, but it makes me itch. I want to stand up and kind of just move around a little bit more.
Yeah. I think it's important to, I don't spend 8 hours a day sitting because I'm trying to work on flow. So I work on flow state 2 times 90 minutes a day, 3 times 90 minutes a day. That's the maximum. The rest, I think that we're just procrastinating. Nothing to do with genetics, but or maybe somehow could be related to genetics. But I think that in terms of education, teaching people how to work would be another chapter in the platform or book of life. Yeah,
I think that would be a really interesting conversation too. I think it's really enlightening to understand what people spend most of their time on. Right? You go through these days and they start passing. You're like, oh, time goes by really fast. And it's like, do you even, you're like, oh, that day went by. What did I even do all day? Right? When you start evaluating how you spend your time, that equals days, weeks, months. That's your life, right?
That's
what are you spending your time?
1 minute at a time, 1 second at a time. Our life is ending. We just tend to forget that. It is so important. And you know what? One of the funniest story on that is people are not even capable of staying with themselves. And it starts from there. We are trying to teach meditation to people, but instead of jumping to meditation, which is a harsh road and implementation to have, let's teach them to accept the fact that you can be by yourself with no phone, no noise, no music, nothing, just you. This is one of the best triggers for neuroplasticity and self-awareness, which is another factor for longevity.
Exactly. Putting away all of the different stimuli, right? That external stimuli and just focusing with self. And I think being okay with that is extremely powerful for our health and our longevity. Yeah. Absolutely.
Getting bored once in a while.
Yeah. When's the last time you got bored, right? You just sat with yourself and thought, look at these colors or listen to these sounds, right? And get stimulated based on more of a natural surrounding rather than picking up phone, laptop, music, right? Music's huge as well. So kind of just putting those away, focusing for 1 second and breathing, taking it all in.
Yeah, being yourself, life on purpose. Absolutely. Anna, it's a fantastic pleasure having you. You're like full of passion, like energy, passion, everything is behind that. If I can ask you one last question on this, is how people can get their test or order the test or get tested or work with you. What's the pathway to follow for that?
Yeah, I'd love to hear from anyone and everyone, even if you just want to introduce yourself and say hi to me. So you can reach me on Instagram, Everything Epigenetics. My DMs are open. That's probably the easiest way. If you want to test, you go to truediagnostic.com, purchase a kit. Happy to do a report review with anyone who takes that test as well personally. So just feel free to reach out. Email Hannah, HANNAH, at everythingepigenetics.com too.
Pretty easy, yeah.
Yeah.
Thank you, Anna. It was a great pleasure having you. I'm through.
Yeah, thanks, Jeez. Thank you so much. I appreciate you having me. Bye-bye.
Bye-bye.